Welcome to Spaceverse, your portal to cosmic adventures. There's strong evidence suggesting that billions of years ago, asteroid collisions may have played a crucial role in bringing the building blocks of life to Earth. Over time, more asteroid impacts delivered key elements that allowed life to evolve and flourish on our planet. But not all asteroid impacts have been helpful. One massive collision is believed to have caused a mass extinction, wiping out much of life on Earth at the time. Despite these ups and downs, Earth has been home to an incredible variety of life for billions of years, and we'd rather not have any more asteroid impacts. Thank you very much. Asteroids, however, move beyond our control. There are plenty of them in our solar system that could cause massive damage if they were to collide with Earth. While many pass by harmlessly, scientists keep a vigilant watch over any asteroids that could pose a threat in the future. By tracking their paths, they can predict if there's any risk of a collision. But what if our understanding of how asteroids move isn't entirely accurate? What if there's something we haven't considered that's affecting their trajectories? Recently, while studying the path of an asteroid, scientists made a surprising discovery, one that has raised some concerns. They're now keeping a close eye on an asteroid named Apophis, which is expected to pass unusually close to Earth in 2029. So, what did they discover, and why are they so worried about Apophis's approach? It all began in 2023 on a bright morning in the Utah desert. A spacecraft returned to Earth after completing one of the most extraordinary missions in human exploration. It had traveled over 2 billion miles, carrying a capsule filled with a precious sample from an ancient asteroid named Bennu. Bennu, a rotating top-shaped asteroid just 500 meters wide, is like a cosmic time capsule holding the secrets of our solar system's birth over 4.5 billion years ago. Made of loose rubble, it's believed to contain primordial compounds, including organic molecules that may have played a role in the emergence of life on Earth. In October 2020, the OSIRIS-REx spacecraft touched down on Bennu's surface and collected fragments that could reveal clues about the early building blocks of our planet. The data from this mission has already provided valuable insights into planetary science, but Q Date-Tsai, a physicist at Los Alamos National Laboratory, took a closer look at Bennu's orbit using data from OSIRIS-REx and earlier ground-based observations. After reviewing the data, he noticed something unexpected and wondered, is there anything in Bennu's path that doesn't quite add up? Could there be a subtle force, too small to measure directly, but strong enough to change the asteroid's course? His team's research suggests that tiny, almost undetectable shifts in Bennu's orbit might point to the presence of an unknown force. As Yu Date-Tsai put it, the trajectories of objects often reveal anomalies that can lead to new discoveries in physics. Here's how scientists uncover the unknown force. Imagine you're playing a game of billiards, but instead of the balls rolling in a straight line, each one follows a slightly different path, as though an invisible hand is nudging them. You start to suspect that the table might be slightly tilted. Even though you can't see the tilt, you can clearly see its effect on the balls. Similarly, while examining the orbital data of the asteroid Bennu, scientists noticed something odd and began to suspect that an unknown force might be influencing the asteroid's movement. This discovery raised concerns because it reveals gaps in our understanding of how objects move through space. This uncertainty makes it harder to predict asteroid trajectories accurately. With the close approach of the Apophis asteroid in 2029, this is especially troubling. On April 13, 2029, Apophis will pass within just 20,000 miles of Earth, close enough to be visible to the naked eye in some parts of the world. While scientists currently believe it won't collide with Earth, even small errors in their predictions could have serious consequences for future encounters. This 370-meter asteroid has been tracked by scientists for years, but recent findings have raised alarms about an increased risk of a collision. The discovery of unknown forces affecting asteroid movements has made it even more urgent to track Apophis. Scientists are using Apophis close paths in 2029 to closely study its path, better understand these mysterious forces, and improve their ability to predict its future movements. But this isn't the only concern that's got scientists on edge. In a groundbreaking study, Canadian astronomer Paul Wiegert has challenged previous assumptions about Apophis's orbit. His research suggests there's a slight but significant possibility that the asteroid's path could be altered, potentially putting it on a collision course with Earth in 2029. This dramatic revision has shaken the scientific community. Weigert's study offers a new perspective on Apophis, noting that while its orbit is currently considered safe for the next century, even a small collision with a space object, like a tiny asteroid or debris, could change its trajectory. This shift could potentially send Apophis toward Earth. Using computer models, Weigert's team analyzed the chances of such an event occurring before Apophis' close flyby in 2029. They found that something as small as a 0.6-meter object could alter Apophis's path enough to push it into what's called a keyhole trajectory, a gravitational path that could lead to a future collision. While the odds of this happening are incredibly low, less than 1 in 2 billion for 2029 and less than 1 in a million for a delayed impact, if the conditions were right, only about 5% of such collisions would actually send Apophis on a path toward Earth. In total, the likelihood of an asteroid impact pushing Apophis into an Earth collision trajectory is less than 1 in 2 billion. Although the chances are exceptionally small, they're not zero. The study highlights how unpredictable space can be, where even tiny collisions can have huge consequences. It reinforces the importance of constantly monitoring not only large near-Earth objects like Apophis, but also smaller debris that could indirectly pose a threat. Besides Apophis, there are other asteroids that scientists are closely monitoring for their potential risk to Earth. One such asteroid is 2007 feet 3, which is about 340 meters in diameter, and has a 1 in 11.5 million chance of impacting Earth on March 3, 2030. In a related effort, NASA recently conducted a hypothetical exercise to assess the planet's preparedness for an asteroid impact. The scenario involved an asteroid, previously undetected because of its orbit around the Sun, heading straight for Earth. The asteroid was estimated to be large enough to cause significant regional damage and was projected to hit Earth in 2038. Participants were told it was between 60 and 800 meters wide, with a 72% chance of impact. However, only 6 months remain before telescopes could gather more details about the asteroid. Despite having 14 years to prepare, the exercise concluded that humanity is not adequately equipped to prevent such a catastrophe. Initial observations were too limited to determine the asteroid's size, composition, or exact trajectory. Adding to the challenge, the asteroid was expected to pass behind the Sun, making it invisible for a critical 7-month period. The exercise revealed several key challenges in planetary defense, particularly the lack of resources to deflect or disrupt an asteroid on short notice. Current technologies, such as kinetic impactors or nuclear devices, would need years of development and testing before they could be deployed effectively. This recent exercise serves as a wake-up call for the global community, emphasizing the need to prioritize planetary defense and highlighting that while asteroid impacts are rare, they are a real threat that demands proactive action to protect our planet. The discovery of an unknown force affecting asteroid movements has thrown scientists for a loop, making it harder to predict future asteroid impacts. Asteroids like Bennu have shown strange behaviors that hint at the presence of subtle yet powerful forces we don't fully grasp yet. This uncertainty makes it tricky to predict asteroid paths with precision, especially over long periods. Even the smallest miscalculations could set off a chain of events, potentially sending an asteroid off course and straight toward Earth. It's a reminder that space is full of surprises, and the smallest changes could have huge consequences. And that's a wrap for today's journey through the cosmos. From the mysterious forces shifting asteroid paths to the unexpected discoveries shaking up our understanding of space, it's clear that our universe still has plenty of secrets to reveal. As always, stay curious and keep looking up because you never know what might be out there.